Hi, welcome back to the Honors Geometry series. In this video, we're going to talk about coordinate proofs. So I want to write a coordinate proof, and given the isosceles right triangle, clean up some of the symbols here. Right triangle ABC, with angle ABC being the right angle, and M is the midpoint of AC. I want to prove that BM is perpendicular to AC. So there are a few things we need to understand. First, how to draw the picture. I want to use the origin whenever possible, just because it makes life easier for me. 0, 0 is a much easier coordinate to work with and to do algebra on than any other coordinate. I'm going to do my A, B, C. We said B was the right angle, so angle ABC is your right angle. M is the midpoint of AC. Doesn't have to be perfect. There's M. And BM, I want to prove that BM and AC are perpendicular. Let's establish some coordinates. I'm going to let A be 0, A. We said this was an isosceles right triangle. So I'm going to let this be 0, A. So this is A units long, which means that this is also A units long on the bottom. So if that bottom side is A units long, then this should be A, 0, and this would be 0, 0. So let A be 0, A, let B be 0, 0, let C be A, 0. So that's one. Now, it says I want to prove that BM is perpendicular to AC. So what I'm going to have to do is I need to understand a few things about perpendicular. First of all, I need to know what M is. That's going to be important later. But what does it mean to be perpendicular? To be perpendicular, especially on a coordinate plane, that means that I need opposite reciprocal slopes. So opposite reciprocal slopes for AC and BM. I need to show that those slopes are opposite reciprocals. So I need to understand first how to find M. So by the midpoint formula, I need to know what the midpoint formula is, and I need to know how to use it to find the midpoint of AC. So M is, you add up your x's and divide by 2, add up your y's and divide by 2. So M would be A over 2, A over 2. So this is A over 2, A over 2. Okay. Now this is where we get kind of into the really kind of messy algebra. So I want to show that those slopes are opposite reciprocals. So I'm going to find the slopes of BM and AC. And with each step, really what you're doing is you're identifying what is your process. So what are you finding first? You're finding your coordinates. Then once you have your coordinates, what do you need? You've got to find your last coordinate. And once you have those coordinates, in each step, you're just telling me what algebra you're going to do. So here I'm just telling the reader of this proof that I'm going to find the slopes of BM and AC. So BM that slope would be, let's see, y2 minus y1 over x2 minus x1 would be a over 2 divided by a over 2. And I can simplify this because what is anything divided by itself? It's 1, or 1 over 1. Now for AC, I've got y2 minus y1 over x2 minus x1, which is a over negative a. Anything divided by itself is 1, but I have a negative, so this is a negative 1 over 1. And again, the goal was that I would need opposite reciprocal slopes for those. And here, we can see that I've got opposite reciprocal slopes. So I can state that because the slopes of BM and AC are opposite reciprocals, BM would be perpendicular to AC. All right, let's try one more proof. I want to write the coordinate proof to show that the midsegment joining the midpoints of two sides of a triangle is parallel to the third side of that triangle. Well, it said triangle. Okay, well, I might as well create a triangle. It didn't tell me what kind of triangle, so I cannot assume it's isosceles. I can't assume it's equilateral. I have to make the most general triangle I can. But I can still use 0, 0. And I can still use two other points. So I'm going to use the triangle ABC just as a very general, nondescript triangle. And I'm going to try to make these coordinates as generic as possible. I don't want to assume anything about these coordinates. So this could be a length of A, and we could say that this is, I don't know, BC. But really what we need to do here is we need to make sure that we take the hint that was given to us and use coordinates with multiples of 2. We'll see why in just a second. So the reason why we're using multiples of 2 is because of my midpoint formula. So here I need to find the midpoint. So first of all, we should establish what our coordinates are. I'm going to say let A be 0, 0. Let B be 2B, 2C. Let C be 2A, 0. And again, it doesn't matter what variable you use, as long as you've got the most generic possible triangle. You don't want to assume anything. So there's my triangle. And let's read through that problem again. What are the key words or phrases? I'm going to need a midsegment. So write a coordinate proof to show the midsegment. That's interesting. Joining the midpoints of two sides. So it looks like I'm going to need the midpoints of two sides. And you could pick any two sides. I want to use those two, because I want to show that it's parallel to the third side. I want to show it's parallel to this side. And that's going to be a little bit easier to use. Always try to use the axes if you can. Always try to use the origin, because that's going to make life a little bit easier for you. So I want to show that this segment here is parallel to the third side. Okay, well, what are some things that I know about parallel lines? What do I need to show? And this is just a note for myself. It's not really necessary to have in your proof. So if the line is parallel, then they should have the same slope. So I need to show that, and let me introduce some letters here, D and E. So I should say that, let the midpoint of AB be D. Let the midpoint of BC be E. And I'll have to find those coordinates in just a minute. But I need to show that DE and AC have the same slope. That's what I really need to show. So how do I do that? Well, first of all, I need to find the coordinates of D and E. So find coordinates of D and E. So D, I know, is going to be, what is that, 2B plus 0 over 2, 2C plus 0 over 2. And this is why we used 2B and 2C and 2A instead of just A, B, and C, because now my coordinates here are B, C. So this is B, comma, C. And E is going to be 2B plus 2A over 2, and then 2C plus 0 over 2, which is B plus A, C. And what I need to show again, right, my whole point is I want to show that that's parallel to the third side. So I want to show that these two segments are parallel. So what do I need to show? I need to show that their slopes are the same. So I'm going to find the slopes of AC and DE. So AC, if I do the slope formula, y2 minus y1 over x2 minus x1 is 0 over 2a, or 0, okay. DE, that slope would be, let me just fill that in. This we said was B plus A, comma, C. DE would be B plus A minus B over, I'm sorry, that's wrong. DE would be y2 minus y1 over x2 minus x1, which would be C minus C is 0 over A, which is just 0 again. So because, and this is I guess, step 5, the slopes of AC and DE are the same, AC would be parallel to DE. So that's what I'm trying to prove. I'm trying to prove that the mid-segment is parallel to the third side of the triangle, and I did that. This mid-segment is parallel to the third side by showing that these two slopes are equal. So those were 2 examples of coordinate proofs. If you'd like to try the coordinate proof of this challenge problem, this is a really tough one here since there's no coordinate plane. Let me know what questions you've got, and I will see you soon.